Hello students, good morning. Today we are going to see the unit 7, that is the new lesson, thermodynamics. Okay, so till now you didn't study about the thermodynamics. Thermo means that is heat, dynamics means that is flow. What are the main objectives of this chapter? We are going to learn that. First one is, we are in this chapter we are going to learn what is the distinguish between the system and the surroundings. What are the term used in this? What are the system? What are the closed system, open system, and the isolated system? Next one is, what is meant by state function and path function? What is the relation between the internal energy, work, and the heat? What are the 4 laws of thermodynamics, and what is meant by internal energy changes and their measurement? Next one is, what is meant by enthalpy change of various types of reaction? So next one is, how to apply the Hess's law using calculation of lattice energy of the crystal. Next one is, what is meant by spontaneous and non-spontaneous reaction, and what is meant by gives free energy, that is the delta G. These are all we are going to learn for this chapter. Okay, next one is, what is the introduction? What is mean by thermodynamics? I already, thermo mean that is heat, dynamics mean flow, that is the heat flow. So in our daily life we come across this so many useful reactions, such as burning of fuel, that is the heat energy, will be flow of electrons, circuit to the electrical energy. So these are all the thermodynamic study of the thermodynamics is the study of the transformation of energy, that is one energy is converted into another form of the energy. So why they are introducing the thermodynamics law? So in the 19th century the scientists are improve the efficiency of the steam engine, so that is they are introducing the thermodynamics law. So these laws have been used to deduce the powerful mathematical relationship applicable for the ranges of uses. Another one is, this thermodynamics evaluate the macroscopic property. Microscopic property mean that is minute properties. So macroscopic property, heat and the work. So in this one it is independent of this equilibrium. What is mean by word equilibrium? So last year you learned what is the word meaning of equilibrium. Equilibrium means once the system is attained that equilibrium, no more reaction will take place. So அப்படினா என்ன அர்த்தம்? once ஒரு reaction வந்து equilibrium attain பண்ணிடுச்சு அப்படினா further எந்த reaction நடக்காது. So that is the final stage of that reaction. Okay, so next one is, what are the principles? These are 3 laws of thermodynamics: first law, second law, and the third law. Okay, so these are all the laws used in the thermodynamics. So this is the another one. Next one is third law, first law, second law, the different forms of energy. What is mean by third law? So third law is the entropy of the unattainability, absolute 0 Kelvin. That is the enthalpy of this unattainability is absolute 0 Kelvin. So what is the meaning for that? The absolute temperature will be 0. So that is the third law. So next we are going to see the first detail about these things. First you learn what is the terms are involved in this system and the thermodynamics. First we are going to see the what is mean by system. So what is mean by system? So first we are going to see the suppose we are considered one in the school. So in the school means, so that is the school is the universe, right? So one of our classroom is the system and the surroundings. So what is mean by system, what is mean by surroundings, and what is mean by boundary? So here that is the universe. So the universe is the school, in our classroom is the surroundings and the system. So okay, so the system அப்படினா நம்ம கிளாஸ் ரூம் எடுத்து நம்ம கிளாஸ் ரூம்ல உள்ள இருந்து ஒரு எக்ஸ்பெரிமெண்ட் வச்சு பண்ணிட்டு இருக்கோம் அப்படினா, இப்போ say for example, so suppose heating process will be takes place inside the classroom. The heating of that solution, particular solution, that is called a system. Okay, the classroom is the surrounding, and the out of this classroom, that is called as universe. Okay, that is the system's universe and the surrounding. The system is not a computer, the system is the working. So any work done by the system, so that is called as work. So system, the universe is divided into 2 parts, the system and the surrounding. The system is the part of the universe which is under thermodynamic consideration. So it is separated from the rest of the universe by real or imaginary boundary. So here that is the boundary. This is the classroom. If suppose we are closing the classroom, mean that is called as boundary. So inside, what is mean by system? Here the system is there. What is system? System அப்படினு சொன்னா ஒரு பீக்கர்ல எடுத்து ஒரு ஹாட் வாட்டர் எடுத்து பீக்கர்ல ஒரு சொல்யூஷனை வச்சு ஹீட் பண்றோம், that is called as system. So then surrounding, out of the classroom, that is called as surrounding. Okay, this is the system and the surroundings. Okay, so this is the another one. So next one is the example. So next one is example. What is the example? The system may be water in a beaker, a balloon filled with water or air, an aqueous solution of glucose. On the basis of the physical and chemical properties, system can be divided into two types. What is mean by system? System can be divided in two types, that is homogeneous, and what is another one is heterogeneous. Homo means same, hetero means different. So homogeneous means same phases. The physical state of all constituents are the same. Suppose we are taking one solution, say for example sugar and water. Sugar and water, so sugar is dissolved in that water, so we are obtained the clear solution, that is called as homogeneous. So what is meant by heterogeneous? Oil and water, that is called as heterogeneous. The physical state of all constituents, example oil and water. So next one is what is meant by surrounding. Surrounding everything in the universe that is not the part of the system is called surrounding. So what is the meaning for that? Everything in the universe, ellame surroundings tha and not part in the system. So that is the surroundings. Next, what is meant by boundary? Anything which separate the system from its surrounding is called boundary. What is meant by boundary? It is separated from the system and the boundary. So the system and the surrounding, that is called as boundary. So next one is what is meant by types of the system. There are three types of system. First one is open system. Open system, which can exchange neither matter nor energy when the surroundings is called the isolated system. What is meant by isolated system? So his boundary is sealed and insulated. So example thermoflask. So thermoflask isolated system அப்படினா, so thermoflask எடுத்துக்கலாம். Flaskல என்ன நடக்கும்? Suppose you are taking the hot water inside the flask, so the heat still maintained till the more than 8 hours. So okay, so that is the condition for the thermoflask. So here what will happen inside that flask, because that heat can exchange with the system. So inside, this is the isolated system, the thermoflask, the heat can exchange with the system and the surroundings. The system can both the energy, in this isolated system both the energy and matter neither enter nor leave the system. So only within the system only the heat can exchange within the system. So இதில இருந்து heat வந்து நமக்கு surroundings விட்டு வெளியிலயும் போகாது உள்ளேயும் வராது. So that is called as isolated system. So that is neither matter nor energy with the surroundings is called isolated. What is meant by isolated system? Neither nor energy surroundings is called the isolated system. So next one is what is meant by closed system. A system which can exchange only energy but not matter is surrounding is called closed system. Closed system அப்படின்னா, suppose we are taking normal steel container. Okay, we are taking the normal steel container, we are taking in a hot water in the steel container, we are taking in a particular place. What will happen? After sometimes we are removing that container, what will happen? The bottom of the table will be very heat. What will happen? The heat can exchange with the system and the surrounding. That is called as closed system. So the boundary is sealed but not insulated. But here the boundary is closed but not by hot water contained. A closed beaker is an example closed system. In this system is transferred to the surrounding but no matter or water vapor can escape from the system. A gas contained a cylinder fit with the piston constitute the closed system. Closed systemனா என்ன? இப்போ ஒரு கண்டெய்னர்ல ஹாட் வாட்டர் எடுத்துக்கிறோம், அதை ஒரு டேபிள்ல நல்லா க்ளோஸ் பண்ணியிருக்கிறோம் அந்த கண்டெய்னரை. ஸோ இப்போ ஒரு பிளேஸில் வச்சுட்டோம் அப்படின்னா கொஞ்ச நேரம் கழிச்சு அந்த பிளேஸை பார்த்தா என்ன இருக்கும், உங்களுக்கு நல்லா வாட்டர் வந்து நல்லா ஹாட்டாக இருக்கும். அந்த பிளேஸ் வந்து டேபிள், இப்போ சப்போஸ் டேபிளில் வச்சோம் அப்படின்னா அந்த டேபிள் வந்து நல்லா ஹீட்டாக இருக்கும். ஸோ அப்போ என்ன நடந்திருக்காங்க? வாட் வில் ஹேப்பன்? த ஹீட் கேன் எக்ஸ்சேஞ்ச் வித் த சிஸ்டம் அண்ட் த சரௌண்டிங். சிஸ்டம்னா என்னது? அந்த கண்டெய்னர், தட் இஸ் த சிஸ்டம். சரௌண்டிங்ஸ் என்ன? அந்த டேபிள் தான் சரௌண்டிங்ஸ். அப்போ அந்த சிஸ்டத்துக்கும் சரௌண்டிங்ஸ்க்கும் ஹீட் எக்ஸ்சேஞ்ச் ஆயிருக்கு, ஆனால் வந்து வாட்டர் எதுவுமே வெளியில் வரல. ஸோ தட் இஸ் கால்ட் அஸ் க்ளோஸ்டு சிஸ்டம். வாட் இஸ் மீன் பை ஓப்பன் சிஸ்டம்? So a system which can change both matter and energy with its surroundings. So a system can exchange with the system and the surroundings. So that is called as open system. Say for example, a hot water containing in a open beaker, continuously heating that beaker. What will happen? So continuously the water will be evaporated, finally the nothing will be there. So that is the heat and the system. In this system both matter and energy is transferred to the surrounding. So here only heat and the matter, the water vapor is also exchange with the surroundings. All living things or chemical reactions are open system because they exchange matter. So all the living things are open system. So we can exchange the heat and the energy with the system and the surrounding. Suppose we are considered as ourselves is a system. What will happen? We can exchange with the air, with the system and the surrounding. So we systemல இருந்து நம்ம surroundingsக்கு நம்ம ஹீட்டை வந்து எவ்வளோனாலும் நம்ம எக்ஸ்சேஞ்ச் பண்ணுறோம். So that is called as all living things are chemical reactions are open system because they exchange matter and energy with the surroundings. Okay, so this is the another one. So next one is Next one is what is mean by intensive property and what is mean by extensive properties. What is mean by intensive property? So in this intensive property, the system depends upon its mass and the size of this property. Do not depend on its mass or size. It is what is mean by it is classified two properties, intensive property and the extensive property. What is mean by intensive property? Intensive properties is the group intensive property is depends on its mass or size. Other properties that is intensive property is extensive properties, it does not depend on the mass. So what is mean by extensive property? Extensive property is the depends upon the mass or the size of the system, and what is mean by intensive property is independent of the mass or the size of the system here. So that is what is mean by in important 2 mark question, what is intensive property. So example, volume, number of moles, mass, that is called as extensive property. What is intensive property? The property that is independent of the mass or the size of the system is called an intensive property. Example, refractive index, surface tension, density, temperature, molar volume. So I am repeatedly asking 2 mark question, what is extensive property? What is intensive property? Extensive property, the property depends on its mass or the size of the system. So what is intensive property? It is independent of the mass or the size of the system. Say for example, volume, number of moles. Suppose we are consider one system in, we can calculate the volume, number of moles, mass, internal energy, that is called as extensive property. So what is intensive property? Refractive index, surface tension, and another one is temperature, boiling point, freezing point, molar volume. These are all called as intensive property. Okay, so next one is what is mean by thermodynamic process. What is mean by thermodynamic process can bring about a change in this. The method of operation which can bring about a change in the system is called thermodynamic process. So what is mean by thermodynamic process? The method of bring the change in the system is called the thermodynamic process. Heating, cooling, expansion, compression, fusion, vaporization, example of a thermodynamic process. These are the example. If suppose we are taking one system in, say heating that system and cooling the system and expansion of the system, compression of the system, these are all called the process of the thermodynamics. Next one is what are the types of process? A thermodynamic process can be carried out in different ways under different conditions. The process consists possible. What is meant by reversible process? What is meant by irreversible process? The process in which system and surroundings can be restored to the initial state. So that is after completing the reaction, the same reaction is after producing the product, after come to the initial state of the final state without producing any changes in the thermodynamic properties, that is called as reversible process. So what is mean by reversible process? So here what is mean by reversible process? The process in which the system and surroundings can be restored to the initial state from the final state without producing any changes. Suppose say for example, without changing in the product, it can come to the reactant. So that is called as reversible process. There are two important conditions for the reversible process. Firstly, the process should occur infinitesimally slowly, and secondly, throughout the process the system and surrounding must be in equilibrium with each other. Suppose what is meant by reversible process? இப்போ ஒரு ரியாக்ஷன் வந்து ஃபைனலாக நடக்குது அப்படின்னா என்ன நடக்கும்? ஒவ்வொரு ஸ்டேஜ்லையும் it is attain the equilibrium. Attain the equilibrium, and another one is it is slowly and secondly. So இது வந்து ஸ்லோவாக நடக்கிறது. So and another one is it is throughout the process, it is occur with the system and the surrounding. Equilibrium occurs with the system and the surrounding. So that is the reversible process. Reversible process, say for example, so what is the reversible process? And another one is what is the irreversible process? So the process in which system and the surroundings cannot be restored to the initial state, and the final state is called irreversible. அப்படின்னா என்ன அர்த்தம்? ஒரு ப்ராடக்ட் ஃபானாக இருக்கணும், மறுபடியும் அந்த ஒரிஜினல் ஸ்டேட்டுக்கு வர முடியாது. அதுக்கு பேர் தான் என்னது? irreversible process. All the process occurring nature are irreversible process. So நேச்சரில் நடக்கிறது எல்லாமே வந்து irreversible process. During this irreversible process, the system and the surroundings are not in equilibrium with each other. So irreversible சிஸ்டத்தில் சிஸ்டமும் சரௌண்டிங்ஸும் வந்து equilibriumல attain பண்ண முடியாது. Okay, so that is the reversible and irreversible process. Okay, so this is the another. So next we are going to see the what is mean by adiabatic process. What is mean by adiabatic process? That is adiabatic process defined as there is no exchange of heat between the system that is no heat flow with the system and the surroundings. Adiabatic process defined as the no heat exchange of heat with the system and the surrounding during this process. So that is called as adiabatic process. So in symbol in one line, there is no exchange with the heat and the system and the surrounding during the changes in the process. So what is meant by thermodynamics? It is changes from the initial state to final state. Thermodynamics changes நடக்குது அப்படின்னா initial ஒரு ஸ்டேஜ்ல இருந்தது, it is converted into another state, right? So during that reaction, it is no heat exchange with the system and the surrounding. Systemum surroundingsக்கும் எந்த ஹீட்டும் எக்ஸ்சேஞ்ச் பண்ணாது. So that is called as adiabatic process. So heat work done by the system in the temperature decreases, work is done on the system, the temperature increases. So the condition, what is the thermally insulating the system in an adiabatic process? If work is done by the system, so work is done by the system, the temperature decreases. அப்படின்னா என்ன அர்த்தம்? ஒரு சிஸ்டம் ஒரு சிஸ்டத்தால் அந்த ஒர்க்கு நடந்துச்சு அப்படின்னா அதனுடைய டெம்பரேச்சர் என்னவாக இருக்கும்? டிக்ரீசஸாக இருக்கும். இப்போ ஒரு சிஸ்டத்து மேலே அந்த ஒர்க்கு நடந்துச்சு அப்படின்னா டெம்பரேச்சர் இன்க்ரீசஸாக இருக்கும். சே ஃபார் எக்ஸாம்பிள், இப்போ நம்ம ஒரு மோட்டர் போட்டுகிட்டே இருக்கிறோம். கண்டினியூஸாக மோட்டர் ஒரு ஆஃப் அன் ஹவர் ஓடினா அந்த மோட்டர் தொட்டு பார்த்தா எப்படி இருக்கும்? ஸோ ஹீட், எனார்மஸ் ஹீட் வில் ப்ரொடியூஸ். ஸோ தட் இஸ் அங்கே டெம்பரேச்சர் வில் பி இன்க்ரீசஸ். ஸோ ஒர்க் இஸ் டன் ஆன் த சிஸ்டம். இப்போ அங்கே சிஸ்டத்தில் ஒர்க் நடந்திருக்கு. ஸோ தட் இஸ் த ஹீட் வில் பி இன்க்ரீசஸ். ஸோ த சிஸ்டம் கேனாட் எக்ஸ்சேஞ்ச் ஹீட் வித் இட் சரௌண்டிங். பட் த ஹீட் என்ன பண்ணும்? அது மேலே தான் இருக்கும். இட் கேனாட் எக்ஸ்சேஞ்ச் வித் த சிஸ்டம் அண்ட் த சரௌண்டிங். ஸோ அடியபேட்டிக் ப்ராசஸ், the heat absorbed is equal to 0. What is Q? Q is equal to 0. And next one is what is meant by isothermal process, in which the temperature of the system remains constant during the changes from initial state. What is meant by the isothermal? Thermal means temperature. The temperature remains constant during the change of the initial state to final state. So what is isothermal process? The temperature remains constant during the changes from initial state to the final state. The system exchanges heat with its surroundings and the temperature of the system remains constant. So what is the meaning for that? So the temperature equal to 0 because the temperature remains constant during the changes from initial state to final state. So what is mean by isobaric process? Isobar mean that is pressure. So the pressure remains constant. So during changes from initial state to final state. So what is isothermal? The temperature remains constant. What is mean by isobaric process? The pressure remains constant during changes from initial state to final state. So that is dP is equal to 0. What is isochoric? Isochoric mean volume. Volume remains constant during changes from initial state to final state. So that is called as isochoric process. Okay, so that is the dV, volume is equal to 0. So what are the things we all learn? First one is isothermal process, temperature remains constant. What is mean by isobaric process? Pressure remains constant. Isochoric process, volume remains constant during changes from initial state to final state. So next one is what is mean by cyclic process? When a system return to its original state after completing a series of changes. Cyclic means it is continuously the initial state repeatedly. The cycle is completed, the process known as cyclic process. In this cyclic process, what is delta U? Internal energy, delta H enthalpy, pressure, volume, temperature. All are equal to 0. Okay, so what are the conditions here? Adiabatic process, Q is equal to 0, dt is equal to dP is equal to 0, isochoric volume, cyclic process, energy, enthalpy, internal energy, enthalpy, pressure and the volume and temperature, everything remain 0. Okay, so next we are going to see the what is meant by state function and path function. So thermodynamic system can be defined by using the variables pressure, volume, temperature and number of moles. A state function of the thermodynamic property system which has a specific value for a given state and does not depend on the path by which the particular state is reached. What is mean by state function? It depends upon the state of the system. So what is the word meaning of state? So that is the physical state of the system, that is the pressure, volume, temperature and number of moles. It depends upon the state function of the system. So ஒரு சிஸ்டம் எந்த அதனுடைய வால்யூம் டெம்பரேச்சரை பொறுத்து அதை கால்குலேட் பண்ணோம் அப்படின்னா that is called as state function. Okay, so this is the another one. So next one is the example pressure, volume, temperature, internal energy, enthalpy, free energy. These are called the state function. Okay, So next one is pressure path function. What is mean by path function? A path function is a thermodynamic property of the system whose depends upon the path by which the system, suppose, depends upon the work done on the system. So இப்போ எந்த ஒரு சிஸ்டம் வேலை செய்தோ அது எந்த வழியில் போகுது. ஸோ இப்போ சப்போஸ் நிறைய ஒர்க் ஆச்சு, அதனுடைய ஹீட் ப்ரொடியூஸ் ஆச்சுன்னா அதை பொறுத்து அதை நம்ம கால்குலேட் பண்ணலாம். ஸோ தட் இஸ் கால்ட் அஸ் பாத் ஃபங்க்ஷன். A path function is a thermodynamic property of the system whose value depends upon the path of the system changes from initial to final state. Example, work and heat. Work will have different values if the process carried out reversibly and irreversibly. So next one is what is meant by internal energy. The energy is a characteristic property of the system which is denoted by the symbol U. The internal energy of the system is equal to the energy processed by all its constituent, namely atoms, ions and molecules. So what is meant by internal energy? So internal system internal energy. So the internal energy, the symbol is U. The internal system is equal to the energy possessed by all its constituent, namely atom, ions and molecules. அப்படின்னா என்ன அர்த்தம்? ஒரு சிஸ்டத்தில் அதனுடைய ஆட்டம், அயான்ஸ், மாலிகுல் அதில் இருக்கிற உள்ள எல்லா ஆல் டுகெதர் அதனுடைய எனர்ஜி வேல்யூ தான் நம்ம என்ன சொல்கிறோம்? இன்டர்னல் எனர்ஜி. The total energy of all molecules in a system is equal to the sum of their translational energy, vibrational energy, rotational energy. So these are all the total energy of molecule of the system. இப்போ ஒரு சிஸ்டம் எடுத்துக்கிட்டோம் அப்படின்னா, சப்போஸ் சேஃபார் ஒரு கெமிக்கல் ரியாக்ஷனே எடுத்துக்கிட்டோம் அப்படின்னா, தட் இஸ் கால்ட் அ சிஸ்டம். அதனுடைய வைப்ரேஷனல் எனர்ஜி, ரொட்டேஷனல் எனர்ஜி, பாண்ட் எனர்ஜி, எலக்ட்ரானிக் எனர்ஜி, எனர்ஜி டியூ டு மாலிகுலர் இன்டராக்ஷன். ஸோ இது எல்லாம் சேர்ந்ததுக்கு தான் பேர் என்னது? இன்டர்னல் எனர்ஜி. ஸோ வாட் இஸ் மீன் பை இன்டர்னல் எனர்ஜி? யுவர் சம் ஆஃப் ஆல் திஸ் இன்டர்னல் எனர்ஜி, தட் இஸ் கால்ட் அஸ் இன்டர்னல் எனர்ஜி. Okay, so next one is the total energy of all the molecules on the system is called internal energy. The thermodynamics one is concerned only the change in the internal energy rather than the absolute value of internal energy. So next one is what are the importance of internal energy? The internal energy possesses a substance differentiate its physical structure. Allotropes of carbon, namely graphite, diamond, differ from each because they possess different internal energy, have different structure. Next we are going to see the characteristics of the internal energy. So what are the characteristics of the internal energy? So first we are going to see the what is the internal energy of the system is an extensive property. So first point is it is an extensive property. So another one is the internal energy of the system is the state function. So I am marking here. You also mark in your textbook. That is the point is enough. So first point is the internal energy of the system is an extensive property, and another one is it is a state function, and another one is it depends only upon the state variable, temperature, volume and the pressure, and another one is the change of the internal energy of the system is expressed as delta U is equal to UF minus UA. UF mean that is energy of final and energy value of initial. So cyclic process, there is no internal energy, delta U is equal to cyclic process, delta U is equal to 0. Okay, that another one is if the internal energy of the system in the final state is less than the internal energy of the system in the initial state. So what is if the internal energy of the system of the final state is less means the internal energy of the initial state there would be negative. Suppose the internal energy is negative means the final value, the internal energy delta U is equal to negative means the final value is lesser and the initial value is greater. So initial value அப்படினா என்ன அர்த்தம்? initial value அதிகமா இருந்துச்சு அப்படினா final value கம்மியா இருந்தது அப்படினா internal energy value என்னவா இருக்கும்? that is நெகட்டிவா இருக்கும். So at the same time, so internal energy, so in the same time the internal energy of the system in the final state is greater. So here, so the internal energy of the system initial state final state is greater. இப்போ final state அதிகமா இருக்கு, initial state கம்மியா இருந்தது அப்படினா the value is become positive. So what is mean by delta U negative means final value is greater, initial value is lesser. The same thing, the delta U value is positive means the final value increases when compared to initial value. Okay. The next one is what are the unit of heat. So what is the unit of heat? Everyone know that calories are joule. Okay, so that is the SI unit of heat is joule. Heat quantity is generally measured in the calories, right? So this is the heat energy. The SI unit of heat is joule, and the calories. The heat is recorded as rise the temperature 1 gram of water is called the vicinity of 15 degrees Celsius. What is the sign convention of heat? The symbol of heat is Q. What is the sign convention? நம்ம ஹீட்டுக்கு வந்து நம்ம எப்படி சைன் கொடுப்போம், பாசிட்டிவா நெகட்டிவா? If heat flow into the system from the surrounding, energy of the system increases, can is taken to be positive. அப்படின்னா ஒரு சிஸ்டம் வந்து ஹீட்டை அப்சர்வ் பண்ணுச்சு அப்படின்னா, ஹீட்டை வந்து வாங்கிக்கிச்சு அப்படின்னா, that is called as plus Q. சப்போஸ் ஒரு ஹீட் ஒரு சிஸ்டத்துலேருந்து வெளியில் வந்தது ஹீட் அப்படின்னா, that is the minus. So that is the, hence it is taken to the negative, flow out of the system into the surroundings. So that is called as minus Q, plus Q and the minus Q. So what is mean by flow into the system, that is plus Q, flow out of the system, that is called as minus Q. So another one is work is done as the force multiplied by the displacement. So what is mean by work? W is equal to F into X. So that is work. Work means work ஒரு இடத்துல வேலை நடந்திருக்கு. So அப்போ வந்து force, the negative sign is introduced indicate the work has been done by the system by spending a part of its internal energy. So இப்போ ஒரு இடத்துல வேலை செய்தோம் அப்படின்னா நான் எப்படி ஞாபகம் வச்சுக்கிறது? So work is done by the system அப்படின்னா நம்ம வேலை செய்திருக்கிறோம். அப்போ நம்ம வேலை செய்யும்போது நமக்கு நிறைய எனர்ஜி வந்து ரிலீஸ் ஆகும். So that is minus symbol. So that is the minus value. So negative sign introduced, they indicate the work has been done by the system by spending a part of its work. Okay, so that is what is the path function. So it is a path function, obviously only the what is the characteristics of the work. First one is it is a path function, appears only at the boundary of the system. So when you are understand work is done by the system means after appear in the boundary of the system. அப்படின்னா என்ன அர்த்தம்? இப்போ நான் ஒரு இடத்துல வேலை செய்திருக்கேன், எப்படி தெரியும்? நல்ல ஸ்வெட் ஆகி வரும்போது தெரியும் உனக்கு. ஸோ இவங்க ஏதோ வேலை செய்துட்டு வந்திருக்கிறாங்க. So that is the system, that is appears only at the boundary of the system, appears during the change in the state of the system. So ஒரு ஸ்டேட்லேருந்து இன்னொரு ஸ்டேட் மாறும்போது அங்கே உனக்கு நடக்கும். Next one is in thermodynamics, surrounding is so large the macroscopic changes surroundings is do not happen. So surroundings is வந்து பெருசாக இருக்கும். So that is the system can changes from one state to the other state. In thermodynamics, surroundings is so large that macroscopic changes mean heat and the temperature, heat and the work can changes. Okay, what are the units of work? So what are the units of work? SI unit of work is joule, which is defined as the work done by a force on Newton through a displacement of 1 meter. We often use kilojoule for large quantities of work. Next one is what is the sign conventional work, the symbol of work. So here also work done by the system means minus value, work on the system means that is plus W. So here work is done by the system. Here work is done by the system, that is minus W. Work on the system means that is plus W. The same thing, heat is observed by the system means that is plus W. Heat is flow out of the system means that is called as minus Q, plus Q and the minus Q. This is another one. So next one is what are the pressure and volume work. So this is can be it is elementary thermodynamics, only type of work generally considered in the expansion of a gases. This is known as pressure volume work, that is PV work or expansion work. What is the relation between pressure and the volume work? So this is one experiment is there. So we see the next video. Okay, thank you children.